Hey, this is Mr. Ford. I'll be doing a lesson on 8.1, finding angle measures and polygons. So we'll go right into it. So a polygon is a closed plane figure formed by three consecutive side segments that intersect at their endpoints. Consecutive vertices in a polygon are two vertices that are at the endpoints of the same side. So here's an example. So this side here, AB, my endpoints are A and B. Okay? On this line here, my endpoints are A and E. So just two consecutive vertices in the same side. Okay? A diagonal connects two non-consecutive endpoints. So that's anytime it goes like across. So like BE is one, BD is one. So BE, BD. All right, so it's just connecting two non-consecutive endpoints. Okay? So then we're going to talk about two different things today, right? So one is called the interior angles. So they're on the inside. So the interior angles are angles at each vertex that are inside of the polygon. So here are some easy ones, right? So I say some polygons are easy to find than others. So this one here, the first one is a triangle. So there's 180 degrees. So I ask myself, how do I find that angle? So I say 180 minus 85 minus 55 is equal to what? And you would say 40 degrees. Then I have this one, right? So it's an equilateral triangle. So it has to add up to 180, and all my angles are the same. So I know the angles have to be 60 degrees. Okay, and then my last one, this shape is supposed to look something like this, but the technology didn't work. Okay, it's a quadrilateral that's separated into two separate triangles. So each triangle is 180 degrees. So I know the whole quadrilateral is equal to 360 degrees. Okay, so here's what I'm saying next. So the next thing I can say is that now we can divide any sort of polygon in the same way. So I can take like a regular hexagon, for example. From each vertex, I can draw a line to another vertex, creating four different triangles. So in each hexagon, regular or irregular, I can make four different triangles. So in each one, there's four triangles, and in each triangle, there's 180 degrees, right? So I say each one of these is 720 degrees. Okay, so I should notice a pattern here. So I say there's four different triangles, and there's 6 different sides, right? So keep that in mind. So what do we notice here? We say that this hexagon and this hexagon have the same degrees, right? This method of breaking it down into triangles is called partitioning or dissecting. Okay, so what we noticed earlier is that there's 4 triangles in a hexagon, so 2 less. So here's the formula today, right? So it says the sum of interior angles, so all of the interior angles added together, is the formula is n minus 2 times 180. So however many sides you have, you plug however many sides you have, so sides, into that number there. So that's the sum. Okay, if I want one individual angle, I use this formula. N minus 2 times 180 divided by n. So that only works for regular hexagons, or regular polygons, sorry. So all of our regular polygons, their sides are the same and their angles are the same. So I can use that formula there. Okay, so this formula is consistent for all polynomials. So again, this is for the sum and this is for an individual. Okay, so this is the second thing that we're going to learn today. This says the exterior angle of a polygon is an angle that forms a linear pair with one of the interior angles of the polygon. The exterior angles of a polygon are formed when a side of the polygon and there's an extension of its adjacent side. So this is my original quadrilateral. And I extend each side, and this angle here is the exterior angle. Okay, here's something important to know. The interior angle plus the exterior angle is equal to 360. So all of the angles added together around are 360 degrees. Okay, so I say the sum of all exterior angles is 360 degrees. I don't care what size of polygon it is. It could be a quadrilateral or a polygon with 100 million sides. They're always going to add to 360. So if I want to find one of those angles, one of these exterior angles here, I say 360 divided by the number of sides. Okay, so let's do some example problems. So in this first one, this has 8 sides. So we're going to call that an octagon. So to find the sum of the interior angles, I use my formula, n minus 2 times 180. So I'll do 8 minus 2 times 180. Okay, so I get 6 times 180, which is 1,080 degrees. Okay, on the next one, I have 7 sides. So this is called a septagon. Okay, in a septagon, I have 7 sides. So I'm finding the sum of interior angles. So I'll say 7 minus 2 times 180. So I get 900 degrees. Okay, then here in the last one, I have a 10-sided shape. So that's called a decagon. Okay, so I'll say 10 minus 2 times 180. So 10 minus 2 times 180 is 1,440 degrees. Okay, so this says find the missing interior angle. Okay, so to find this, I take the number of sides minus 2 times 180. Okay, so I know that's going to be equal to 360. So I say I need to find this angle. So I say 360 minus 105 minus 113 minus 75 is equal to my missing angle. So I'll say 360 minus 105 minus 113 minus 360 minus 105 minus 113 minus 75 is 67 degrees. So I know that's 67 degrees. Okay, this one says find the missing angle. I know that all the angles added together are 360 degrees. So to find the missing angle, I'm going to come up here, I'm going to say x plus 75 plus 90 plus 115 equals 360. Okay, so then I'll simply add those together. So 75 plus 90 plus 115 is equal to 280. So x plus 280 equals 360. So subtract 280. So I know x is just equal to 80. So x is equal to 80. Okay, number 4 says find the number of degrees in the sum of interior angles of a decagon. Okay, so sum of interior angles, I think n minus 2 times 180. So a decagon has 10 sides, so 10 minus 2 times 180. So I know that's just equal to 1,440 degrees. Okay, number 5 says find the number of degrees in the sum of interior degrees and interior angles of a regular pentagon. Okay, so here's my formula, n minus 2 times 180. So I'll say 5 minus 2 times 180. Okay, so that's just equal to 540 degrees. Okay, 6 says find the sum of exterior angles of a pentagon, decagon, or a billionagon. Here's what you need to know. It's kind of a trick. It's always 360 degrees. Okay, always, no matter what size the polygon is. It's the exterior angles always add up to 360 degrees. So 7 says find the measure of each exterior angle of a regular octagon. So exterior angle, I think this formula, 360 divided by n. So I say 360 divided by 8. Let's do that, 360 divided by 8 is 45 degrees. Okay, so 360 divided by 8 is 45 degrees. Okay, so 8 says the sum of the interior angles of a convex polygon is 900 degrees, right? So I'll say the sum of interior angles, so n minus 2 times 180 equals 900, right? So what I'm saying is I already know the degrees, boom, okay? Now I just have to figure out how many sides, and I have to classify it. So to get n by itself, I divide both sides by 180. So I'll do 900 divided by 180, which is just 5. So I'll get n minus 2 equals 5. So I'll add 2 to the other side, so I get n equals 7. So that's called a septagon or a heptagon. Okay, number 9 says the sum of interior angles is a convex polygon. Let's say, call this 1440 degrees. Classify the polygon by its number of sides. So again, I'll say n minus 2 times 180 equals 1440. So I'll say, divide both sides by 180. So I'll say 1440 divided by 180 is equal to 8. So n minus 2 equals 8. So then n is equal to 10, or called a decagon. So you always want to make sure if it has a special name that you include the special name. Okay, 10 says find the measure of each interior angle in a regular dodecagon. Okay, so a dodecagon is 12 sides. Okay, so it says find each. Each means 1. So we're going to use the n minus 2 times 180 divided by n. Not going to do that yet. N. Okay, so I say 12 minus 2 times 180 divided by 12. Okay, so I'll do that. 12 minus 2 times 180 divided by 12. This is 150 degrees. So the interior, one of the interior angles is 150 degrees. Now, number 11 says find the measure of each exterior angle in a regular dodecagon. So exterior, remember I said interior angles plus exterior angles always equal 180. So I could have said 180 minus 150 is equal to 30. So I could have said that, right? But I'm going to use, so I could have done it that way, but I could have also said the exterior angle, so 360 divided by 12, okay, that's also going to be 30 degrees. So this is the exterior angle formula. Okay, so that is 360 divided by n. Okay, 12 says each interior angle of a regular n-gon has a measure of 156. How many sides does the polygon have? So if I said the interior angle is 156, the exterior angle is 180 minus 156. So that's just 24 degrees. So by the exterior angles theorem, I could say 360 divided by n is equal to 24. Okay, I can rewrite that by multiplying both sides by n. So 360 equals 24n. So n equals 360 divided by 24. And let's put that into our calculator. So 360 divided by 4, or by 360 divided by 24 is 15. So n is equal to 15. Okay, number 13 says each exterior angle of a regular n-gon is 9 degrees. How many sides does the n-gon have? So I could say 360 divided by n is equal to 9 degrees. Okay, so I multiply both sides by n. So I get 360 equals 9n. Okay, then I'll do 360 divided by 9. So I get n is equal to 40. So this has 40 sides. Anyways, thank you for watching, and you can ask me any questions if you have anything to add.